In this lab, we're going to calculate the specific heat for two metals. So first we'll take our styrofoam cup and put it onto the balance and record our mass as 1.76 grams. Now we're going to add some water to our cup, leaving enough room so it doesn't overflow when we put our metal into the cup. And we'll put it back on the balance, and we're going to record our new mass, 146.34 grams. Next, we're going to want to know what the temperature of our metal is. And right now the metal is in some boiling water, so the temperature of the water will be equal to the temperature of the metal. So I'll put our probe in, and then I'll call up our software, and we'll give it a minute for that temperature to stabilize, and we'll record the temperature of the water in the beaker, which will be equal to the temperature of the metal initially. And that temperature is continuing to go up, so we're going to wait until it stabilizes. Getting close. All right, so we're going to record that temperature as 98.8 degrees Celsius, and that's our initial temperature for our metal. What we're going to do next is we're going to take that temperature probe out. We're going to take our cup and put it into a beaker so that we've got some more insulation. We're going to put our probe back into that water, and we're going to record the temperature of our water, and that'll be our initial temperature for our water. And again, we're going to want to wait until that temperature stabilizes, and we'll record the temperature of the water. Now, while we're waiting for that temperature to stabilize, let's just talk about what's going to happen. We're going to take the hot metal out of the water. We're going to move it into the cup of water, and energy is going to be transferred from the hot metal to the water in the cup. The temperature of the metal is going to go down as it loses energy. The temperature of the water is going to go up as it gains energy. And eventually the temperature of the water and the metal will be the same, and that will be our final temperature for our water and our metal. So we're going to record the temperature of our water as 22.0 degrees Celsius. I want to keep that up there. Now what we're going to do is take our, I'm going to move this over a little bit so we can see a little better. I'm going to take our metal out of the boiling water, and as quickly as possible, I'm going to move it into our cup. Now, energy is going to be transferred to the air as we do that, and there's really not much we can do about that. We're just going to try and minimize that as much as possible, and we're going to want to record what the final temperature of the water and the metal is. And again, keeping in mind that energy is being transferred from the metal to the water until their temperatures are the same. So our final temperature for the water and the metal is going to be 24 point, we want the highest temperature, so it was 24.7 degrees. And the reason we don't want to record the temperature once it starts going down again is because energy is actually being released from the water and the metal into the air, so eventually that temperature will drop back down to the temperature in the room. So our last step, we're going to take the metal out of the cup and we're going to dry it off and we're going to mass it again. So we'll take that metal out of the water and we'll dry it off with a paper towel. And we'll put it back on the balance. And that's going to tell us, we'll get rid of the thermometer. It's going to tell us what the mass of the metal is, which is 32.27 grams. Now we have all the information we need in order to calculate the specific heat for this piece of metal. And actually it's 32.26 grams, so that's what we'll record that final pressure as, or temperature as. Now we're going to complete this lab again using our second metal. So the mass of the cup is still 1.76 grams since we're using the same cup. The mass of the cup and the water is still 146.34 grams. And now we want to measure the initial temperature of the metal. And again, the initial temperature of the metal is going to be the temperature of the water bath that the metal is in. So we'll call back up our thermometer, and we'll wait for that temperature to stabilize, and we'll record the initial temperature of our metal. So now that that temperature has stabilized, we're going to record the initial temperature of the metal as 98.8 degrees Celsius. And we're going to move the thermometer into our cup of water. So we'll take the cup of water, put it into our beaker, move the thermometer into that beaker of water, and wait for that temperature to stabilize again. So the initial temperature of the water is 25.2 degrees Celsius. And again, what we're going to do is take our metal out of the boiling water and transfer it to our cup of water and measure what the final temperature is. And again, energy is being transferred from the metal into the water. The temperature of the metal is going down as it loses energy. The temperature of the water is going up as it gains energy. And eventually the temperature of the metal and the water will be the same. And we want to record what that final temperature is. And it happens pretty quickly. We want the highest possible temperature. So 27.5 will be our 27.6 will be our final temperature. Now we're going to take the metal out of the water and get the final temperature of, or final mass for our metal. And then we'll have everything we need in order to figure out the specific heat for our second metal. So our final mass for the metal is 57.28 grams. We have all the information we need to figure out the specific heat for both of our metals. Go ahead and do that, and then we will go over the results.